Hi, and welcome to Xamarin University. My name's Kim Philpotts, and this is Android 101, ListViews and Adapters in Android. You can see my name and my email address at the bottom of this slide, so please feel free to shoot me an email at any time. Also, you should make sure that you have the class materials downloaded, which are available at university.xamarin.com. In this class, we're going to work with the list view and two different types of adapters that supply rows to list views. Our objectives are, first, to use the array adapter to populate a list view with some simple data. Then we're going to look at responding to item click events to determine which item was selected by a user. Then we're going to code our own adapter to customize the row UI. Then we're going to look at a few common performance optimizations that you'll want to do when you're using list views. And finally, we'll help the user navigate large lists of data by showing pop-up section headers to let them know where they are in the list. So by the end of the class, you'll have seen all the core concepts of a list view and adapters, and also have coded a few of the most common performance optimizations. So let's start off by talking about how we populate a list view using an array adapter. So an array adapter will let you get your data into a list view with an absolute minimum of coding. And the task that we're going to perform is we're basically going to build a complete application that displays a list. And we'll be using an array adapter to populate that list view. So the UI for the rows is actually going to be very simple. And our array adapter is a convenient mechanism to do this. But its simplicity means that it's often best for prototyping or for cases where your data is actually just a collection of strings. What we're going to do is we're going to add a list view to an activity, use an array adapter to populate that list view, and then we'll talk about some of the limitations of the array adapter. Let's start off with what a list view actually is. So a list view is going to show your data in a sequence of rows, and it's much like a list box in Windows or a UI table view in iOS. It's a control that's actually used in most applications, and it's pretty hard to come up with a non-trivial application that doesn't have a list view incorporated somewhere, possibly with the exception of games. Closely related to list views are adapters, and it's the job of the adapter to create rows as the list view asks for them. The list view will tell the adapter the position it needs, and then the adapter will create the row using its data. So we have this situation where the list view will say, for example, I want a row for element 6 in our list, and then the adapter will go and get the data and then provide that row. When we look at creating our own adapters later on, we'll see how that information is passed to the adapter and how the adapter actually passes that row back. But in our example here on the slide, we have a list of instructor data on the left that we want to render out to a list view on the right. And the adapter is going to be asked for a row, and it's going to look up the data for the instructor, and then it's going to create that row. More specifically, it's actually going to create an image view and two text views, and use the values inside the instructor object to populate the views. And then that row is passed back to the list view. Adapters actually have a lot of flexibility in how they render their rows. Rows can use different layouts based on the data that they want to accommodate. For example, alternating rows could use layouts that look inverted, as is common in something like a chat application. Let's turn our attention to the array adapter now. It actually doesn't differ much from the description of our standard adapter that we just went through. The only real difference is the array adapter is one of the bolt-in adapters that we can't modify too much, and what it does is display rows in a single piece of string information. In the background, we're going to give the adapter the same list of instructors, but it will just use a toString call on our data to populate our single text view inside the layout file. Array adapters have a bit of a problem with performance, and the reason for this is that because we're using a built-in class, each of those string objects is going to have to be converted to a java.lang.object, so each of those objects will become a Java object that needs to be managed and garbage collected on the Android side. This isn't much of a problem for small lists, but for large lists it becomes a noticeable problem. But having said that, the array adapter is actually a very quick and easy way to do prototypes for small lists. In general though, the best practice is pretty much to implement your own custom adapters, and we'll look at that a little later on. Let's have a look at some code on how to use an array adapter. So we start off by defining a list of elements, and in our case, a list of instructors. Next, we create a new instance of an array adapter, and you'll notice that there's a generic version that specifies a type of instructors. And even though we specify instructors, it's still going to call toString on those objects. So it's important that you have a meaningful toString override on your objects. Let's talk about the parameters now. The first parameter for the constructor of the array adapter is called the context. And because an activity inherits from context, we can actually pass it this. The reason we need the context is so that it knows where it can get its resources from. The next parameter specifies the layout file ID. In our exercise, we're going to use one of the built-in layouts called Simple List Item 1. You could of course specify your own layout file here, but the thing to remember is that because we're using an array adapter, even if your layout has multiple text boxes, only one of them will actually be filled in with information. And the third parameter is the collection of data we want to display. Once we've constructed the adapter, we're going to need to assign it to a list view. And the way we're going to do that is first we're going to find our list view by using the find view by ID. And then once we have our list view, we're going to assign the array adapter to the adapter property of the list view. So you can see using the array adapter is a really simple way of implementing a list view. It's time now for an individual exercise. And in this exercise, we're going to get some practice using the array adapter. This is exercise 1 in your downloadable class materials. So let's jump over and open up the starthere.html file in the downloads and have a look. So if we scroll now down to the link for exercise 1 and click on the link, we can have a look at the exercise. The primary goal of this lab is to display a collection of data in a list view. And we're going to use the array adapter class, which is useful for displaying simple list views that only have a single string for each row. We're going to create an application called Xamarin University that will display a list of Xamarin University instructors. And each instructor has a name, a photo, a speciality, and a biography. The finished project will look a little like this. There's also some provided resources in the Part 1 resources folder you'll need to complete this lab. We have the instructor.cs file, which contains a simple class to represent an instructor. The instructor.data.cs file, which creates and populates a list of instructor objects. And an icon.png, which contains the Xamarin University icon. Down below, there's the steps to walk through if you need them, but I recommend trying it out yourself without the steps if you can. Also, there is a Part 1 completed folder which contains a completed version of the lab that you can use to check your work. So pause the video now and do the exercise. And once you've finished, unpause the video and you can watch as I go through the exercise file. Okay, let's go through the exercise together now. So the first thing we want to do is create a new project. So I'll be doing this in Xamarin Studio. You could also do this in Visual Studio if you like. I can create a new solution either by selecting the New Solution button or going up to the File menu and clicking New Solution. So we'll create a new Android application and we'll call it Xamarin University, and then just hit Next and then Create. Our next step is to remove the unneeded template code. So let's open up our resources/layout/main.axml file, and we'll get rid of that button from the layout. So to do that, we can just select it and then hit the delete key. And now let's remove some of the template code from mainActivity.cs. So open up mainActivity.cs and we'll remove some of the code that's put in by the template. Now we want to add some branding to our application. So in the mainActivity.cs file, let's locate the activity attribute on the mainActivity class and we'll change the value of the label property to be instructors. Next, we want to add our icon in. So what we're going to do is we're going to get rid of all of these drawable folders. So we can highlight those and select remove. Now we'll add a new drawable folder in. And then we'll import the icon PNG file from the Part 1 resources. Now we'll run our application and see what we have. So now we can see our application, which has the Xamarin University icon and also the label of instructors. Now let's add in the starter code. So let's add the files instructor.cs and instructordata.cs from the Part 1 resources folder of the project. So let's go and have a look at the instructor file. So we'll open up instructor.cs. And you'll see here that it's a very simple class. It just has 4 properties. It has a name, an image URL, a speciality, and a biography. But also, quite importantly, it has a toString override. And remember that the array adapter will call the toString in order to get its value. So you must have a toString if you're using your own class like we are here. Next, let's have a look at the instructordata.cs file. And notice that we have a static constructor that creates a list of instructor objects that's sorted by name. The actual creation of the objects is done in the add instructors method. And finally, note the static property named instructors up the top here that returns the list of instructor objects. And so now we've got our data in place. Let's go and modify our main.axml file and add a list view into our layout. And we can do that by selecting a list view from our toolbox and then dragging it over onto our linear layout. We'll give it an ID of instructor list view so that we can access it from our code behind. And let's also just check that the layout width is set to match parent and the layout height is also set to match parent, and that'll just make sure it takes up the entire screen. We'll just do a quick build now just to make sure that the ID is generated into the resource file so that we can use it in just a moment when we want to use our find view by ID. So now let's add some code in. Let's go over to our main activity.cs and we're going to use find view by ID to get a reference to the instructor list view. And now we'll create an array adapter. We'll put that into a variable called adapter. And when we create our array adapter, we need to pass it 3 things into our constructor. First, we're going to put in the context, and we can use our activity here. So we'll just use this. And next, we need an ID of a layout file to use for the row. We're going to use one of the predefined Android layouts. So we'll use android.resource.layout.simpleListItem1. And our final parameter is our collection of instructors. So now let's load that array adapter into the adapter property of our list view. And now let's run our application and see what we've got. And we can see each of the instructors' names and their speciality displayed in the list. It's time for a quick flash quiz to test our knowledge up until this point. Question 1. How are rows in a list view created? A. The list view creates them using data template. B. The list view asks the adapter for each row as it's needed. Or C. Rows are always strings, so there's no need to create them. The correct answer is B. The list view asks the adapter for each row as needed. Question 2. What is an array adapter's key limitation? Is it A. Data objects must be in an array. B. The rows it builds do not support item click events. Or C. It can only populate one text view. And the correct answer is C. Using an array adapter, it only populates one text view. Question 3. How does array adapter convert the code behind data into a string? Is it A. It calls the toString method. B. It serializes the object to XML. Or C. It uses reflection to get the first string property in an object. And the correct answer is A. It'll just call the toString method. Let's just summarize the points up until here. So we've added a list view to our UI, and we've also used an array adapter to populate a list view with some simple data. And we've also had a bit of a look at the limitations of an array adapter. Let's move on to our next objective. The objective here is to see how to respond when a user clicks on an item in a list. So to handle an item click event, there are two key things we need to know. We need to know how to subscribe to the event and also how to figure out which item was actually clicked. To handle a click of an item, we subscribe to the ListView.itemClick event. And when this gets called, we get an event argument that indicates the position of the item that was clicked. The list view also has an event named click that's actually raised for clicks on the list view itself rather than items in the list. And this is generally not useful, and Android will actually raise a runtime exception if you subscribe to the click on a list view. The event exists on a list view because it's actually defined on the base type. List view also has an item selected event, and this won't get raised in touch mode, so item click is generally considered to be a bit more useful. It's now time for another individual exercise, and this time we're going to have a look at exercise 2, which is how to handle list item click events. So what we're going to do is subscribe to the list view item click event, and when the user clicks on an item in the list, we'll display an alert dialog that shows which item was clicked. Let's go to the starthere.html page and click on the exercise link for exercise 2. In this exercise, we're going to get some practice responding to list item selection and then the event arguments that are passed when an item is clicked. Down below, we can see an image of how the application will look at the end of the exercise. On the left is the list of instructors, and on the right is the same list after an item click event. And you'll notice how the alert dialog shows the name of the instructor that was clicked. The exercise consists of 3 small steps. First, we subscribe to the item click event on the instructor list view. Then, in the event handler, we use the position property that comes from the event args to determine which instructor was clicked. And finally, we display an alert containing the name of the clicked instructor. Down the bottom of the exercise page, there are the steps if you require them. So go ahead and pause the video now, do the lab, and when you're finished, unpause the video and I'll go through the lab steps as well. I'm going to head over to Xamarin Studio, and I've loaded Lab 1 completed file from the class materials as a starting point. So the first thing we want to do is go to the main activity and hook up an item click event on the instructor list. And you can do this actually in numerous ways, but I'm just going to do it old school with an onItemClick event. Now I'll put in the onItemClick event handler with a sender parameter and a adapter view itemClick event args. Now I want to get the instructor that was clicked. I can do this by looking into the instructor data list using the position value that's passed in the event args. So now that I have an instructor, it's simply a matter of showing an alert dialog. So I can use the alert dialog.builder to create a dialog. Then set the message for the dialog. And I'll just use the instructor's name. Then set a neutral button, just with OK. And all I want to do is close the dialog, so I don't need a delegate to actually do anything. So I can put an empty delegate here. And then I have to call dialog.show to actually show the dialog. So let's run the application, and we should be able to see that when I click on an instructor, my alert dialog appears showing the instructor's name. And there we go. As I click on an instructor, a dialog appears showing their name. Fantastic. So let's just summarize where we're up to. We've managed to subscribe to a ListView itemClick event, and also we've had a look at how to determine which list item was clicked. So far, the UI we've created is fairly basic, and it's not going to take us very far. So our next objective is to code up a custom adapter so we can use a complex row layout. And our row will display the instructor's name, their speciality, and a photo. We want to write our own adapter so we get full control over the way the row looks. And the key operation is creating a row. So you'll need to instantiate a layout file, look up each view in the layout, and then populate the view with its data. Although the built-in array adapter is simple to use, there's a big problem with it when you have more than a few elements. The issue is that it's implemented in Java and wrapped by Xamarin to expose it to our C# code. But it's really a Java object. The data we supply has to also be a Java object, since the JVM can only work with Java strings. So Xamarin wraps or boxes all of your C# objects into Java objects to make them accessible to the array adapter. Each one of these Java wrappers has a reference to the C# representation, so the object is known to both worlds. Even intrinsic types like string and int have to be mapped into the JVM's world, which means they are duplicated and passed over as copies. In that case, they do not hold onto the original C# object, but still, you're using double the memory to represent them. This is important because it causes more work for the memory manager to collect the memory when it's no longer in use. Because the Java objects are holding onto C# objects, and we have C# objects holding onto Java objects, it's not a single sweep to clean them up. The collections must be synchronized between the two memory managers, which means things stay in memory a lot longer, increasing memory pressure, and the cleanup process is a lot more complex, involving multiple collection passes, which increases the CPU load. The second reason you might want to build a custom adapter is because array adapters are limited in terms of how it displays its data, or rather what sort of visual cells it's capable of creating. We have the ability to create simple textual representations of our data, which is okay in some cases, but often we desire more complex data with multiple rows of information and thumbnails to help the user quickly identify important data. Because of these restrictions, you'll almost always want to create a custom adapter and take complete control over the data that's being displayed. And the first step in that is working with the layout inflator. So what is inflation? Well, inflation is loading a layout file and then turning it into an in-memory object graph, or view hierarchy, which we can then make use of. So if we look at this slide, we can see a layout file on the left-hand side. Inflation is going to create a view hierarchy of this over on the right-hand side. And once we have our view hierarchy, we can then access them in code and do things like set properties on them or attach events. There's a library class called Layout Inflator which performs inflation. And the Layout Inflator is an object that we have on our activity. So it'll take a resource ID and turn it into a view hierarchy. We can then use things like find view by ID to work on the view hierarchy and to look up the views inside. The array adapter up until now has been smart enough to take a text field and find a text view and then set the value for it. But before we can use this, we actually need to talk about adapters. Any custom adapter we write is going to inherit from the base adapter type. So on this slide here, we have our base adapter and it has 4 methods which we need to implement for it to function properly. The first is the getView, which is going to return us a row for a particular position. We also have an indexer. So given a list position, it will return the object of that position. And this is primarily used as a convenience for you so you can get your data directly from the list view. There's a list view method named getItemAtPosition that uses this indexer to get the object. Next, we have the count property, which returns the number of items in the collection. We also have getItemID, which returns whatever you'd like to use for your IDs in your data. So if your objects have a unique ID, you can use them. If not, it's fairly common for simple cases to use the list position as the ID. The ID gets passed to you in the event args of the item click event, so you should choose an ID that will let you uniquely identify each of your rows in the data items. So now let's look at getView, because that's where the magic really happens. And it's where we're going to inflate the view and then put in the values. So getView produces a row by inflating a layout file and then populating the views with some code behind data. You need to have an activity available so that you can get a layout inflator. So most custom adapters require an activity as a constructor parameter, and that's what we'll do here. So the basic operation of the getView is, first it inflates a layout file, then it looks up the views in the hierarchy, and then it populates the view with your data from the position. So basically it takes a list position as a parameter and returns a row UI for that position. It's time for another individual exercise. This is exercise 3 in the class materials. So let's go over and have a look at the exercise description. The primary goal of this lab is to code an adapter for your list view to display the data. The steps you'll perform are, first you'll use a custom layout file containing a relative layout and 1 image view and 2 text views. Then we'll write some code to pull data out of your instructor objects and load it into the views of the row, and then we'll return that row. After this exercise, you should have an app that looks like this. There are some resources you'll require that you'll import from the resources folder. First, we have the instructor row.axml, which contains the layout with views that you want to display for each of your instructors. And we have an images folder which contains the instructor photos. Down the bottom are the steps outlined, but as always, give this a go first with the knowledge that you've gained so far. So pause the video now and do the lab. When you've finished, unpause the video and I'll walk through the steps. Okay, let's jump over to Xamarin Studio and have a look at the steps for exercise 3. Our first step is to import the starter resources. So first we'll import the image resources. To do this, we'll add them to the assets file. First, I'll right click on the assets folder and then select add existing folder. Now we select the images folder from the part 3 resources. We want to import the entire folder, so select the folder and click OK. And you want to copy the files to the directory, so select that and then click OK. Now we just want to check the build actions for the imported images. We can do this by right clicking on an image and going down to the build actions and check that Android asset is checked. Another way you can do this is by clicking on the properties and look over at the properties pad at the build action. Next we'll add the layout file to the resources layout folder. Right click on it and select add files and then add the instructor row.axml. Again, we want to copy the files to the directory and click OK. Let's have a quick look at the instructor row.xml. So double click on that. The layout file looks a bit funny in the Visual Designer, so let's look at the source XML. And we can see here that we have a relative layout, and inside that we have an image view with an ID of photo image view, a text view with an ID of name text field, and another text view with an ID of specialty text view. Our next step is to implement our custom adapter. So we'll add a new class called instructorAdapter.cs. We'll give that the name instructorAdapter. Okay, now we'll set the base class for this to be base adapter. And we're going to use instructors. So we just need to add a namespace in there. Now we'll want to implement the required interface, and you can do this in Xamarin Studio by right-clicking on the base adapter and selecting Refactor. Implement abstract members. Now specify where you want to put this, and we'll just put it under the constructor. Now let's modify the constructor of our adapter. It'll need a reference to activity, and it uses that for the layout inflator. It'll also need a reference to the collection of instructors. Just resolve some namespaces. Now we'll store these values away in a couple of fields. So we'll add the context field and the instructors list. Just add that field in, and we'll add the instructors list. And then we'll store away that list of instructors that was passed into our constructor. Now we'll go ahead and implement the members of our base adapter. First we have getItemID, and we're just going to use the position in the list as the ID, so we can just return the position. Let's move down to the count property. And for this we just return the count from the instructors list. And now we'll implement the indexer. And for this, we can return the instructor at the specified index. Now let's go back up to getView. The first thing we want to do is inflate a layout for our instructor row, and we can use context.layoutInflator. .inflate. The first parameter is the resource ID, which in our case is resource.layout.instructorRow. Next, we specify the view group, which is just our parent, which is the list view. And for the last parameter, we can just return false. So now we want to use the find view by ID to find our values inside the layout we just inflated. First, we'll have a look at the photo image view. Next, the name text view. And finally, the specialty text view. Now we want to populate those views with some data. So let's start off with our photo. We can do this by using a stream to open our image asset. We just set the namespace. And we can use the image URL from the instructor for this. Now we'll want to create a drawable from the stream. We'll just set a namespace for that. And then we can assign that drawable into the photo image view by using set image view. Now we'll set the name of the instructor and finally the speciality. And now that we have that all set up, we can return our new view. But before we can run this, we need to use our new adapter in the main activity.cs. So let's double click on that. So let's create a new instructor adapter and we'll pass in the activity and the list of instructors. Now we'll change our instructor list to use our new adapter. First, we'll get rid of what's there at the moment, and then we'll use our new adapter. And let's try running that. Oops. Okay. I should probably change that to use the variable and not the type name. So let's try that again. And there we have it, our new app using our custom adapter and our instructor row layout. And we can click on the items in the list view and get the names of the instructors. So that's all we have to do to create our own adapter. So let's just summarize what we did in that lab. First, we had a look at how we can inflate a layout file with our layout inflator. And then we had a look at how to code up a custom adapter and use that from our activity. Now that we have a working custom adapter, our next goal is to add a few performance optimizations. We'll work through two common techniques. First, we'll look at reusing layouts to reduce memory usage. Secondly, we want to cache our view references, which will allow us to save some CPU cycles. Both of these patterns are extremely common in the Android community. You're likely to see them in most of the adapters that you look at. Let's start by talking about list view layout reuse. So as we scroll a list view, the get view is going to be called continuously. And if we're inflating views each time, and we have a long list, that's kind of inefficient because the user can only actually see a small subset of the rows on the screen at any one time. So suppose you have a list of 100 items and a screen that can only show 8 rows at a time. List view really only needs 8 active rows to satisfy the user, and it'd be a waste of memory to keep many more than those 8 rows around. Now think about what should happen when the user scrolls the list. The user can still only see 8 rows, but those rows need to actually show some different data. And the way the list view handles this is by recycling row layouts. A list view sometimes passes an old layout for the adapter to repopulate with new data, which is faster than recreating the layout, and it also uses less memory. The getView method will receive a layout in the convertView property to reuse if one's available. If we look at the code, the first thing we do is we check if that convertView is null. And that'll typically happen at startup when we're still populating our initial rows. But once we've gone through that initial process, we'll typically have rows available and your convert view will be passed a row to reuse. But if the convert view is null, then we need to still inflate a layout. And the bit that's missing from the code on this slide is the bit where we still have to populate the actual view items with data, so as we're replacing the old data with the new data at the new position. And by reusing inflated layouts, what we're doing is we're helping curb allocations. The second optimization would be to factor out all of the find view by ID calls. These take CPU cycles to traverse the view hierarchy and to find the particular view by ID. And to implement this, we're going to use something called the view holder pattern. But before we look at that, let's have a look at a thing called the view.tag property. This is a property that we can use to store additional information we need. And we're going to use it to effectively store the references to the views we want to reuse. Because it's a java.lang.object, we can pretty much store whatever we want in here. And the tag property is defined pretty far up the inheritance hierarchy, right up in the view class. So it's available on most UI types, including any layouts that we inflate for the list view rows. So we're going to create a view holder object which inherits from Java object, so we can store it in the view tag. Inside our view holder class, we're going to have properties for each of our specific views. Now there's nothing special about the name view holder. You can actually use anything you want. But if you follow the view holder naming convention, then other developers will recognize the purpose of the class. Now when you inflate a view, we're going to assign our views into the properties of the view holder and then store them away in the tag. So next, let's have a look at some code on how we can cache our view references. So in the code on the slide here, the first thing that we do is we inflate a layout. And then we use the find view by ID to find all of the views. Then we create a view holder and assign our views to properties within that view holder. And then we place them in the tag for the view. Now if we get a convert view where it's not null, we can then pull out the tag property and have direct access to the views without having to call view.findViewById. It's now time for an exercise to get some practice implementing common list view performance optimizations. This will be exercise 4 in the class materials. I'm now going to open up the exercise file so we can look at the steps. The lab goal is to increase the efficiency of our custom adapter using two common Android techniques, namely layout recycling and the view holder pattern. The high-level steps are, first we're going to increase the amount of data so that the list view actually becomes scrollable. Then we'll look at modifying the getView method to take advantage of layout recycling to reuse some existing rows. And then we'll improve this further by implementing the view holder pattern, which will prevent us from having to look up views inside the layout multiple times. We have some required resources which we'll include into the project. There's an image asset managers.cs file, which creates a cache of drawable resources. There's also a viewholder.cs file, which we'll use to implement the view holder pattern. Down the bottom of the exercise page, there's also the step-by-step instructions that you can go through if you need to. So pause the video now and attempt the lab. And when you're complete, unpause the video and you can watch as I go through the lab as well. So hopefully you got through that exercise okay. And now let's walk through the steps now. I have the starter project open in Xamarin Studio. And our first task is to add more data into the application so we can have enough data to scroll. So go into the instructor data file and uncomment the lines to add extra instructor data. We'll end up with multiple copies of each instructor, but that's okay. We're really just interested in having lots of rows. So now we're going to add the image asset manager class in from the lab resources folder. Now let's open that up and have a look at the get method. So it basically takes an activity and a URL, and if the cache doesn't already have an image specified by the URL, it creates the drawable from the stream and caches it away. Otherwise, it just returns a cache version. Now let's go use it in the instructor adapter. So we'll set the photo using the set image drawable, and we'll use the image asset manager.get method, passing in the URL of the instructor's image. And now we can get rid of that old code that was creating the drawables. We don't need that anymore. And we'll just run the application now just to make sure that we haven't broken anything, and check that we've got lots of rows in our list view. Okay, that's looking fine. Okay, now let's implement the layout recycling. But before we do, I'm just going to show you how nasty not using layout recycling is. So I'm going to just add a count value here. And I'm going to add a breakpoint to output the number of times that the layout is actually inflated. And I'll just edit the properties in the breakpoint so that it outputs a message instead of breaking. So I'll change the breakpoint action to print message and continue, and then set the message to inflate resource and output the count. Just hit apply. Oh, I better increment the count as well. So let's run this and see what we get. So if you notice in the debug window, we're outputting every time we inflate the layout. As I scroll around, you can see how nasty this is and how many layouts are getting inflated. So we definitely want to fix this. So to implement layout recycling, all we have to do is get the convert view. And then if the convert view is null, or in other words, we haven't been passed a row, then we'll inflate a row, just like we've been doing up until now. But if the convert view had a value, then we can just use that without having to do the inflation. So let's run this, and you'll notice that in the output window, we're no longer doing heaps of inflation as we scroll around. We only do the inflation whilst we fill the screen for the first time, and after that, it uses cached versions. Now let's implement the view holder pattern. And the first thing we need to do is add the viewholder.cs file into our solution. And if we actually look at it, it's a really simple class that just has 3 properties to hold our references. But notice it's java.lang.object. And this is so we can put it into the tag property of a row. Now back to the instructor adapter. So let's move these find view by ID calls up into the if statement, because we'll only need to do them once when we inflate a new row. Then what we'll do is we'll create a view holder object. And set the photo, name, and speciality properties to hold the view references. And now we'll add the view holder into the tag of our new view. Now, if we aren't creating a new row, we can retrieve the view holder from the view.tag, remembering, of course, to cast it back to a view holder. And then we can modify the bottom lines to set the view values via the reference in the view holder object. So first the photo. Then the name. And then the speciality. And we're done. So let's run the application again. And we shouldn't notice any visual differences, but our list is going to be much more efficient. So just to recap on that exercise, first we reused inflated layouts to reduce our memory usage, and then we looked at caching view references to increase performance. Now let's move on to our last section, which is enabling fast scrolling and also to code up a section indexer. So ListViews have built-in scrolling, and the default behavior works fine for fairly small lists. But when you have a lot of items, it can get a bit tedious. So sliding your finger doesn't scroll very fast. And if you actually fling the list to move more quickly, then it's pretty hard to tell where you are in the data. We'll do two things to make it easier to navigate a large list. First, we'll turn on fast scrolling to let the user move quickly through the list, but with a little bit more control than just flinging their finger. And second, we'll give the list view section labels to let the user know where they're up to in their data set. So we'll have to calculate what the labels should be, but the list view will display them for us as the user scrolls through the list. To enable fast scrolling, it's actually pretty easy. We just have to set the fast scroll enabled property to true on the list view. But something to keep in mind, even if fast scrolling is enabled, the thumb won't actually appear unless the list has about 3 times as many rows than actual screen real estate. So for example, if you have 8 rows that can fit on your screen, the list would need to have about 24 items or so before it'll actually use fast scrolling. The next bit we want to talk about is bringing up that section index pop-up. And to do that, we're going to have to talk a bit more about the concept of sections. So a section is really just a logical group in a list of data. And the first thing we need to do is define what a reasonable section is. So in our case, we'll look at our instructors and we'll have a section based on the first letter of their last name. But it could just as easily be the cities where they're based or what courses they teach. The important thing is that the data should be sorted on the property that you're going to use for the sections. So a section indexer reports the labels back to the user. And the motivation is that users will want to navigate to a particular section in the list, which is still pretty hard to do even with fast scrolling enabled. So the concept of a section indexer is that it tells the list view about the sections in the data and where the sections are and what label to use for each section. And the list view shows the pop-up section label as the user scrolls through the list using the thumb. So to code up our section indexer, we need to implement the iSection indexer interface on our adapter. Just keep in mind it lives on the adapter, not on the list view. And also you'll need to have fast scroll enabled set to true for the section labels to actually work. Okay, so we have 3 methods that we need to implement. We have the get sections, the get position for section, and the get section for position. Let's drill into these in a little bit more detail now. So let's look at our first method, which is get sections. So get sections gathers all the section labels into an array. The labels need to be in order inside the array. So for example, if C is the second label, it'll appear in index 1 in the array. And then what we do is we return those labels from this method. And those are the characters that will be used to display. So looking at the table, we have to work out our sections, and each element will conceptually have a list position, a section index, and a section label. Our next method is the get position for section. So get position for section maps the section index to a list position. For example, in the list of names, if you were passed 3 as the section index, you'd return 8, since 3 is the index for the E section, and the first occurrence of a name that begins with E is at position 8 in the list. This method will get called repeatedly by the list view, so pre-computing the values into a map for retrieval is a pretty good strategy. And finally, we have the get section for position. So this does the opposite. It maps a list position to a section index. For example, in the list of names, if you were passed 11 as the position, you should return 3, since list position 11 is part of section 3. Again, this method gets called repeatedly by the list view, so pre-computing the values and storing them away in a map is a good idea. And now for our last exercise. So the purpose of this exercise is to improve the scrolling experience for the user. And we're going to look at two things. We're going to look at enabling fast scrolling, and we're also going to be looking at implementing the section indexer. So let's just jump over to the exercise file. So this is exercise 5. And as I mentioned, the goal here is to improve the user experience when scrolling a list view through a large data set. We're going to do this in two ways. First, we're going to enable an enhanced scroll bar with a high rate of motion. And secondly, we're going to provide pop-up section headers to inform the user of their progress through the data set as they scroll. The finished application will look like this here. There's two high-level steps. First, we're going to use the ListView.FastScroll enabled to turn on our fast scrolling. And then we're going to implement the iSection indexer interface on our custom adapter, which will provide our section headers. There's a section index builder.cs file, which is in the assets folder, and that class performs most of the implementation of the section indexer. Down below are the steps for the lab. But as always, give it a go with the knowledge you've already gained first. And so if you want to pause the video now and complete the lab, and then once you've finished that, unpause the video and we'll go through it together. I'm over in Xamarin Studio now. So let's have a look at implementing our first step, which is to enable the fast scrolling. So if we go over to our main activity.cs, all we need to do is come down here into the instructor list and set instructor list dot fast scroll enabled equal to true. And that will turn on our fast scrolling list. So next we need to make sure that we actually have enough data for our instructors in our data set. So let's go to instructor data and just uncomment a few of these add instructors to give us enough data. And now let's run the application, and we should find that we now have a fast scroll handle. As we scroll, we'll see that appear, and we can scroll through there. So you'll notice that's actually pretty cool, but it isn't great for users because they don't know where we are in our list. So to fix that, we're going to implement the iSection indexer. So the first thing that we're going to do is import an already built class. So we'll go add resources, or add files, and we're going to import the section index builder.cs file from the class resources. And we'll copy that in. And And we'll just go and have a look at that. So what this is going to do is build up some structures that will help us implement our section headers and our section for position and the position for section. The actual implementation of these isn't incredibly important. What matters is that we build up these maps. And what these functions actually do is pretty much what we saw in the slides earlier on. They're building up a map for section headers, section for positions, and positions for sections. So now let's go to our instructor adapter because we're going to implement this. So we'll add the interface iSectionIndexer. And then if we right click on that, we can implement the interface. And we'll just put this down under our constructor here. And there we have the three methods that we need to implement. But first of all, what we'll do is we'll come up here and we'll create those maps using the section index builder that we imported. And the first one we'll do is our get section headers, which is a Java Lang object. And we can use the section index builder, build section headers, and pass into that our instructor data. Next, we'll implement our get position for section, which returns a dictionary. So we'll create a variable called position for section, and that will come from the section index builder. Build position for section, and again, we'll pass in the instructor data. And lastly, we'll do the section for position map. So again, it's a dictionary with ints, and we'll call it section for position map. And we can get that from our section index builder, build section for position map. And once more passing in our instructor data. So now that we have our map in place, we can actually go and implement these methods. So we'll start off with our get position for section. And for this, we can just return from our position for section map. And if we pass it in the section index, we can return that value. Likewise, our get section for position, we just need to return from our section for position map based on the position. And for our get sections, we can just return our section headers. So we can go return section headers. So as you can see, all of the hard work is done in that section index builder. But if we run the application now, we can now see as we drag that fast scroll handle, we can see the section indexes appearing in that pop-up. And now the user knows where they're up to in the list as well. And now it's time for a flash quiz to test our knowledge out. Question 1. Which list view event is raised when the user clicks on a row? Is it A, click, B, item click, or C, item selected? And the correct answer is B, item click. Question 2. What is inflation? Is it A, populating a list with rows, B, creating a drawable from an asset file, C, loading code behind data into a views of a row, or D, creating a view hierarchy from a layout file? And the correct answer is D. Inflation creates a view hierarchy from a layout file. Question 3. If you implement a view holder pattern correctly, how many times will you use find view by ID to locate each view in a row's view hierarchy? Is it A, 0, B, 1, or C, 2? The correct answer is, of course, B, 1. If you implement the view holder pattern correctly, you should only have to use find view by ID once to locate each of your views. Question 4. To provide indexing, you must implement the iSection indexer on which class? A, the list view itself, B, your custom adapter, or C, your main activity. And the correct answer is B. You implement the iSection indexer on your custom adapter. Question 5. Get section for position maps indices from A, a list position to a section index, B, a section index to a list position, or C, a view position to a list position. And the correct answer is A. It maps list positions to a section index. So let's just recap what we did in that last exercise. First, we enabled our list view fast scrolling by setting the fast scroll is enabled property. And then we went through and implemented the iSection indexer on a custom adapter. And that brings us to the end of Android 110, list views and adapters in Android. Thank you very much for watching the video. I hope you've learned a thing or two. And always feel free to email me if you've got any questions. And I hope to see you on some courses. Have a nice day.